All right, so we're gonna be looking at part B now. I'll give you. I said this thing died too. All right, part B is x squared plus 9x plus blank equals something where you have x blank squared. I'll let you finish it. B divided by 2. Oh, -7. Yes, sir. You said decimals. I heard Desmos, which is a online calculator. I was like, really? Decimals, yeah. You shouldn't have been. Oh, actually, I guess you would. Keep them as fractions. I gotcha. All right, so sorry, the formula is b divided by 2 squared. So in okay, so we get 9 divided by 2 squared. Convert that. Uh-huh. Perfect. Right, and then she took that and converted it into a fraction. Hmm. Okay, are you able to do that on those calculators? I know you had the decimal, the something was FD or DS or something. Yeah, perfect. So that's how I got it. All right, so this one's just b divided by 2. So this is just going to be positive 9 divided by 2, which can't be simplified. So it's just plus 9 over 2. Yes, ma'am. Hmm. This is because I know the formula. You'll get to it. Formula. Hmm. Yeah, I know. 9/4. Oh, in the calculator, did you do 9 divided by 2 squared, no parentheses? It only squared the bottom. Yeah, but 9/2 in parentheses. So it squares both of them. Yeah, so what the calculator just did, it was like, oh, you want me to just square the 2 since there was no parentheses, and then it made it 9/4. That calculators can be smart, but you have to type it like exactly what you want it to do. All right, so with that, now let's solve one so we can see the full process. So number 2, it's going to tell you to solve by completing the square. All right. First thing you want to do, if the c that is given is not already moved over, move it over. In this case, it is. Then you're going to do this. You're going to add that blank that we were given on one in A and B. The issue is if I add that blank over here on the left, I have to add that blank on the right. Meaning, I don't know what our number is, but let's say I add a 4 over here. I have to add that same 4 over here, or I have changed the value of this equation. I have, whatever I do to the left, I have to do to the right. Okay, so I added a blank on both sides. Now, what goes in the blank is your b divided by 2 squared. So write down a note over here, b divided by 2 squared. Remember, this is your a, this is your b. You're trying to find your c. A better c, because that 31 wasn't a good c. Square. Oh, I got you. I was like, huh? I wrote the 2. Square. Or an exponent of 2, or a power of 2, or however you want it. Yeah, I got you. Well, you said all you said all under 2. I was like, I did write the 2. And I was like, okay, I got you. It's all right. Correct. It's it's going to be on both sides. Yep. It'll go on both of these blanks. Correct. So in this case, what is negative 10 divided by 2? Okay. And then negative 5 squared would be 25. So I am adding 25 on both sides. So that's step 1. Step 2 is to now turn this trinomial to make it look like this guy right here. So this trinomial, once you get a perfect C, will always be 2 parentheses with whatever this letter is, squared. But to figure out what goes in this space is b divided by 2 only, no square. So what is negative 10 divided by 2? Negative 5. So that is what went here. So this trinomial just turned into this binomial. And then you just actually add these. So what's 31 plus 25? 56. Now I'm back to where I started on 16.1. That's it. That's it. Or square root, x minus 5. I'm not going to forget plus or minus. What 2 numbers multiply to 56? 8 and 7. What 2 things multiply to 8? What 2 things multiply to 4? So what can I pull out? Here goes a 2. Who got left behind? What am I going to do with that 7 and 2? Multiply them, and I get 14. Not quite. How do I get rid of this -5? 3, yeah. Nope. Just like in 16.1, I couldn't add it to anything else attached to a square root. So when I take this 5 and I add it over here, correct. Right. And Dante had asked that, or no, Jennifer had asked that. Does it matter where it goes in the front? It just looks cleaner in the front, so I don't have to say plus or minus 2 square root of 14 plus 5. Too many pluses going on there, and that's the process. Oh, that's right. This weekend, Saturday. Just gotcha. Nice. Square root. Mm-hmm. And then I'm correct. Yes. Yes. You multiply each group, so it'll be 2 times 2 times 2, so it'll be 8. Yeah. So, for instance, I don't remember what the number was, but if I get a 2 here, and another 2 here, and a 2 here, and another 2 here, and a 2 here, whatever the numbers are, right? That'll be 1, 2. That'll be 1, 2. That will be 1, 2. So it becomes 2 times 2 times 2. Excuse me, 8. So I would multiply multiple groups of numbers. Yeah, it can be. I can see that. All right, let's try another one. Number 3, 2x squared plus 4x minus 12 equals 0. So a couple things here. To do completing the square, this has to be a 1. So what can I divide 2 by to make it a 1? So I'm going to have to divide every single one of these by 2. Because before I can do completing squared, there can be no number in front of my x squared. Whatever this number is right here, I'm going to divide every single number by that. Regardless if it gives me fractions. I cannot have anything in front of that x squared. So that will go away. I'm left with just x squared. 4 divided by 2 is 12 divided by 2 is, and then of course 0 divided by 2 is 0. This is not a perfect C. So I have to move this C over. How do I move it over? On both sides. So I get x squared plus 2x plus my blank equals, I don't know why I make it so big, but, and then 6 plus another blank. So basically the only extra step I had to do here from here is I had to divide by whatever number was in front of the A, and this one I didn't have to, and I had to move that C over. Other than that, I'm right back to where I started on question 2. How do I figure out what number goes here? So 2 divided by 2 squared. Correct. Mm-hmm. Perfect. What is this trinomial going to turn into? A binomial. Not minus, plus 1. And the reason we get this, because this right here is your b divided by 2, no square. So in this case, that's positive 2 divided by 2, which is good. And then 6 plus 1 gives me 7. Now what? Square root it. Sorry, I was right there with you. The 7? Sure. What two numbers multiply 7? 1 and 7, right? Can't go any further. 7's actually a prime number. So therefore the 7 would stay, but what needs to go in front of the square root of 7? There you go, right there. Add it or subtract it. That's it. Mm-hmm. Let's slowly progress a little bit harder. This process, what makes it hard is that you can deal with some fractions. Let your calculator help you do a lot of it for you. There we go. 2x squared plus 2x minus 9 equals 0. What are we doing first? Perfect. These two will go away. These two go away. And can I simplify 9 over 2? What do I do next? We're 9.5. And then at the same time, I'm going to go ahead and add my blink. Mhm. Okay. There's an imaginary 1 right here. And this is part of that b divided by 2 formula. Yeah, so we got 1/2 squared from the formula. So b ended up being 1 and then divided by 2 squared. Very good. Perfect. Binomial plus 1/2. Mhm. Yeah. But you get 5/2? You did 9/2 plus 1/4? No, no, I think yours is right. I think. No, 9/2. 9/2. Okay. It's not 9 point, it should be 4.75. There it is. Oh, did it try to like add some other fraction for calculators? Float. Go back to your float. Your float's on. Well, you want it on. I guess your float's off. You want your float on. Mhm. Oh, because it's 1/4. Yeah, that's all right. No, you're good. That's why we practice. All right, so what did we end up getting? 19/4. 19's actually prime, but I can split this up as square root of 19 over the square root of 4, which ends up being 2. So I'm not going to forget the plus or minus. So it's square root of 19 over 2. Yeah, you see it a lot. Oh, well, and that's the thing too, is a lot of students are always like, how do you just know that answer? When you've seen it show up like 52,000 times, you're like, yeah, that's what the answer always is. What's your last move? Huh. Going to subtract it because it is a positive. Very good. You're good. Perfect. Now, I would accept this answer. However, your homework will not. Your homework wants to make this one gigantic fraction. So since they're both divided by 2, I can make one big old fraction with 2 on the bottom and then just write the top. So -1 plus or minus square root of 19. So kind of simplified it in a sense. Oh, I agree. I would prefer the left side, but the right side's what they want. All right, so got another one? Which one's that one? Oh, is that the silver ones? Oh, those are so good. My fave are the those are good. Those are good. I like it's like hot cocoa ones. It's got a marshmallow in the middle of it, and then it's like hot cocoa chocolate powder or something around it. That one's really good. Well, so my grandma, she had big old ones like this, and then also had the popcorn ones. I didn't know that that had cookies and popcorn in it until I was an adult. I thought you bought sewing kits out of these because that's all that was in there. This had sewing little strings, and the other one had the big yarn or whatever that she would knit with. It wasn't until I was an adult that I saw someone walking in the work or something. I was like, "Oh, you're gonna sew something up today?" They're like, they just looked at me puzzled. I was like, "Get your sewing kit right there." They're like, "My cookies?" I was like, what are you talking about? And then she opens it up, like, you put cookies in a sewing kit? Like, I was so thrown off. For Christmas. Yes, yes. Oh gosh, I haven't seen those in forever. Yeah, because I'm pretty sure I got one like every year in my stocking or something, like a little dollar or something in there. Hmm. Our biggest thing was we always got a toothbrush. Uh, yeah, we and my mom still to this day will mail one to my brother, and she comes over to our house for Christmas, and we still get a toothbrush. I'm like, we don't care about anything else, but if you just keep giving that toothbrush, that'd be great. Like, I kind of depend on that now. I get one like every 6 months, and that's kind of how it's are. Yeah. Hmm. Oh, nice. I didn't know that. That's pretty cool. I like that. Yep. That's how that's how we used to do it back then. Your teachers told you they'll take you to the bathroom. Mine just said they'll do it right in the front of the room. Like, no, it was like I'm back an example out of you. All right, let's come back. What do I do first? You would divide it if there was a number next to x squared. Since there's not a number there, I don't have to divide. Good. I gotta move the not good C so we can get a better C. At this point, I'm going to add my blank. Not subtract the 4. I got to figure out what goes in the blank. And that's fine. Very good. Mhm. So I think you're asking where the B is coming from. The B is the second term. Oh, how did we get this four? So four divided by two. Yeah, so I took this B right here, that was right here, and I plugged it in right here to this formula. And then I got the four divided by two. Gotcha. You good? So then what's negative 11 plus four then? Negative seven. And then you take the square root. They're not used to be, but now after the conclusion of chapter 15, we have to keep going. So with the square root of negative 7, don't forget plus or minus. But then this negative, I pull out and it becomes a I. And now it's just a 7, but we just saw in the last question, 7's prime. So it stays as square root of 7. I'm not done. Very good. Perfect. All right. Let's try another one. Oh, oh. Go back, go back, go back. Okay. Ox. Mm-mm. The grade that's in Blackboard will be your grade. Yeah, with them as of last Sunday. Blackboard's where your content is and where your grade is. Content and your grade. So the videos, the syllabus, and then your grades. Yeah, I don't know how Hawks does it. I know there's a grade on Hawks, and I don't know how it's calculated. Because at one point, and I say this because I have a college algebra kid that has a 0, and I even requested for her to drop. And then, like, I don't know, about 7 chapters in, she finally showed up and started doing the work. And at the whole time, it had her as an A in the class. And I was like, she hasn't done anything. Like I was just so thrown off. Yeah. So, but on our Blackboard, it's correct. But on that, I don't know how it's calculating that. Perfect. Thank you. What question was that? 5, so 6. All right, they're gonna try to confuse you by putting the 0 here first. It's just backwards, and it doesn't matter technically where the equal sign is. Absolutely. That's what your first step. You could just do this. Let's flip it. But that's what they're going to try to do on one of the questions. They're going to try to like, oh, we're going to fool you by putting the 0 first. Ah, can't get us. Yeah. There you go. Correct. hmm Perfect. How do I do that? Good. You leave it as a negative. It's inside. Can't do anything. There's no pairs. I don't think I spoke on that problem. Is there any questions on that one? That's good. This is what we're gonna do. Bring the calculator and all of your notes. Monday, 3 hours. Write all the stuff that you do on the pre-test and then bring that to the final. The best thing. Now, on the final, it gives you different problems each time, right? Or is it the same question? Yeah, so you get a good amount of practice. Like, all right, here's like 3 or 4 different examples of. And I will say too, studying also for your final, you can actually go back and review your test, your old test, to see what mistakes you made, so you can make note of not making that on the final, because you're going to see those same type of questions again on the final. Other than there's going to be some chapter 16 at the end, but everything else is the same questions from the first 3 previous tests. 30, 30 questions on the final. That's why you'll get 3 hours. 10 questions a problem, or 10 questions an hour. This comes out to 5 questions a minute. They got this, guys. Actually, no, say that. 6 minutes a question. 6 minutes. There's 60 minutes, not 50 minutes. I don't know. Yeah. All right, so I will say that was pretty much all of completing the square, but then it adds these questions at the end, which I thought were kind of interesting. And I was like, oh, well, this doesn't feel like it actually goes with this section. But now I want you to produce an equation if I give you the zeros. So here we go. So it's going to give you, like, in this case, y equals 4 plus 3i, and y equals 4 minus 3i. And it wants to know what the equation of this guy is. And here's my best device. Get these to set equal to 0. So I'm going to subtract the 4, subtract 3i, move it over there. So I get y minus 4 minus 3i equals 0. Subtract 4, add 3i this time, move it over here. So I get y minus 4 plus 3i equals 0. Yeah, move everything that's on the right side to the left. Because now what I want to do is I want to take this and multiply it to this. So we can do this the foiling process, or we can use the square method. What do y'all prefer? Okay. So now it's going to be a 3-term times a 3-term. So I'll put my y minus 4 minus 3i and my y minus 4 plus 3i. That part of the order doesn't matter. You can put this right over here or this right here. It doesn't really matter. I'm going to pause, let you take this in. Do you understand where I'm heading with this? Oh, then just do regular FOIL. So do y minus 4 minus 3i times y minus 4 plus 3i. And what you'll do is you'll take this y, FOIL, 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 take the negative 4, FOIL, 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 take the negative 3i, FOIL, FOIL, FOIL. With the I times I will give you that I squared, yes. Yeah. So I feel like this organizes your information a little bit better. Mhm. This right here can get kind of crazy and then maybe unorganized as well. I do feel like this method, especially with so much about to happen, that it just keeps your information nice and organized. When you go back to combine like terms, it's a nice, clean diagonals that you're adding, in my opinion. Yeah, that part. And I've also seen some people kind of turn them into vertical methods. So they'll like do all of their Ys and they'll get like these 3 responses, and then they'll do all their negative 4s and get like 3 more responses than the next one. And then that's how they'll combine it that way. I've seen, yeah, I gotcha. Yeah. Let's talk about it. So we get Y times Y, which is Y squared, Y times negative 4, Y times 3i, just 3i times Y, not much more you can do with it. Negative 4 times Y, negative 4 times negative 4, negative 4 times 3i, negative 12i, no Y, I. Y or I? The negative 12i. Yeah. Because there's a negative 4 here and then an I there. And then negative 3i times Y, negative 3i times negative 4, and then oh, gotcha. Okay. Negative 3i times 3i, negative 3 times 3, negative 9, I times I squared. So we learn that that I squared is equal to what? Negative 1. So all it's going to do is change the sign of this number. So this is now just a positive 9. So anytime you have an I squared, it's going to change the sign and make it positive or negative, whatever it might be. So now when I go to combine like terms, there's a couple of things you need to see that will pretty much happen every single time. Negative 3iy and 3iy, what's going to happen to those two? They cancel each other out. What happens to 12i and negative 12i? They cancel. So when I'm combining like terms, I'm going to have a y squared. Combine this diagonal. So negative 4y minus 4y. And then 16 plus 9. No, we turn so that I squared just changed the sign of that negative 9 to a positive 9. Because really what's going on here is negative 9I squared becomes negative 9 times negative 1, since that's what I squared is equal to. And the negative 9 times negative 1 gives me that positive 9. Mm-hmm. Adding 16 plus 9. Yep. Negative 4 plus negative 4 can be negative 8. Yeah, when you with the box method, the diagonals that you add up, the diagonals you add up. But yeah. hmm hmm Because technically what you're doing is combining like terms, which are adding your like terms. All right. That would be the answer. That's what it's looking for. All right, let's try this one. X equals 2 minus 3 square roots of 2, and x equals 2 plus 3 square roots of 2. Ooh, what are you going to do first? Yep, you're going to move everything to the other side. So minus 2 plus 3 square roots of 2. We'll go over here. This will be minus 2 minus 3 square root of 2 goes over here. Yep, because basically what it did is it gave you the answer, and now it wants the equation. So if I was to go backwards, let me go backwards here on this one. If I was to start here, my answer would become 4 plus or minus 3i. That's the answer to that one. So they gave you the answer first, and then you had to take that answer and produce what the question was. So if I was to do the complete in the square like we just did earlier to this problem, I would get this as my answer. 4 plus 3i and 4 minus 3i. Right. And then I'm going to multiply those two together. Mm-hmm. So this becomes minus 2 plus 3 square root of 2. This becomes minus 2 minus 3 square root of 2. Now, these are the terms I'm going to box method. Not yet. Correct. Yeah, these, yeah, I mean, yes, you could do this if you want and then just move it over here, but I'm not really solving for anything in this situation, so I'm not worried about trying to cancel as much as I'm just trying to get it all to one side so I can set up my box correctly. You ready? right? X times x times -2, x times -3 square root of 2, square root of 2x, good. -2 times x, -2 times -2, -2 times -3 square root of 2, perfect. 3 square root of 2 times x, perfect. 3 square root of 2 times -2, oh, I don't know why I put it next there. 3 square root of 2 times -3 square root of 2. Square root of 2 times square root of 2 would give me square root of 4, which is 2. Remember, if I multiply two of the same radicals, the radical will go away and I'll be left with just the radicand. Yeah. So then -9 times 2 gives me -18. So that right there will go away, and this is now going to be -18. So now, again, just like the i's, the square roots kind of do the same thing. What's going to happen to the -3 square roots of 2x and the +3 square roots of 2x? Cancels. What's going to happen to the 6 square root of 2 and the -6 square root of 2? They cancel. So just like the i's, they all canceled. So then I have x squared, -2x plus -2x. Very good. And then 4 plus -18. Four plus -18. There it is. You're good? I like that. I need that. Yeah. Your homework did, so I guess best practice, it probably should put equal zeros back on it. I I want to say on the homework it already had the equal 0 on it. You just had to type in the other box and it was good to go. And so yeah, type equal 0. Let's do one more. X equals 1 plus I square root of 5, and x equals 1 minus I square root of 5. Well, it's not that it's two separate problems. It gives you two zeros and asks for the equation. But yeah, this looks just like, yeah, don't worry. Perfect. Mm-hmm. Oh, x times -1. Yeah, you can just do negative x. But since this is really all your prep work, if you would -1x, there's nothing wrong with that either, so that you know the combined like terms. Yeah, I'm good either way. So x times x, and then of course x times -1 is negative x, or -1x. It doesn't really matter. And then x times I squared of 5 is -1 times x, -1 times -1. Tell me. 1. So two negatives make a positive. You were correct. And then -1 times I squared of 5. Mm-hmm. And then negative square root of, or negative I square root of 5 times x. Very good. Yeah. My part too. Negative I squared root of 5 times -1. Uh-huh. Perfect. And then negative I square root of 5 times I square root of 5. The 1 and the 1? Oh, you mean like I and I would make I squared? So remember, I times I would be I squared, but it would be negative. Right, right, right. Oh, I see what you're saying. I got you. So yeah, so negative I squared. And then you're right. Since I squared does give you a -1, that would kind of just become 1 and kind of cancel out. But then square root of 5 times square root of 5 would be just be 5. So yes, you'd be correct by saying just 5. And to give you a bigger breakdown, negative I squared is negative, and then 5. And so the two negatives there make a positive. So then I'm left with 5. Because the I squared will change the sign. Currently, it's a negative, so now becomes a positive. Here, parentheses, parentheses, -1. Oh, I see. That does look like an I. Yeah, those are parentheses. I was just showing you that I squared gave you the -1. Oh, it's a negative I squared. Oh, shoot. The negative I squared 5 would be the answer. But then to simplify it, I squared is -1. And then a negative -1 produces a positive 1. So that becomes a positive 1 times 5, which would just be 5. Right. So that goes away and I'm just left with 5. And once it becomes an I squared, it becomes some type of number. There's no more I there. So again, just like before, I squared of 5x and negative square root of 5x, what will happen? 1I squared of 5 and -1I squared of 5 will. So then I'm left with x squared, negative x plus negative x, and then 1 plus 5. Oh, yep. Again, I would totally do a 5-minute break here, but we only have 15 minutes. So I'm going to roll on to 16.3. 16.3. Oh, sorry about that. Okay. So 16.3, in my opinion, is my favorite way to solve quadratics, because it's a process that works every time. Regardless if it's factorable or not, this process will always work. And then it's just a bunch of simplifying, right? So 16.3 is quadratic equations, the quadratic formula way. Now, if you are curious about proofs, your book has a great proof of how completing the square made this equation, so that mathematicians didn't have to keep doing completing the square. They could just use this formula that works every time. But I'm not going to waste y'all's time on that. If y'all like to see it, it's in the book. All you need to know, and I used to have my kids memorize this, but you get to use your notes. So this will be x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I do have a jingle with it. X equals negative b plus or minus square root b squared minus 4ac, all over 2a. And the clown pops out. Box. That's it. I think nowadays they have like I don't know, a rap that goes with it. I'm like, I don't know. It's like 2 minutes long. Mine was like 2 seconds long. I don't know whichever one you want to memorize. But again, y'all don't have to memorize it because I get to use it on the test, but you have to be able to utilize it. So let's talk about how we do that. So we get x squared minus 7x plus 4 equals 0. And you're asked to use the quadratic formula. Now, I want to be completely honest with you. When it comes to the test, it might tell you to use a certain way, but how does it know? It doesn't. So out of all the methods that we've seen, factoring, square root, completing the square, and now the quadratic formula, find one you like and go with that one. Now, I will say factoring doesn't work on all of them. Square root method doesn't work on all of them, but completing the square and the quadratic formula works on all of them. So if you're comfortable with factoring, start with that. But once it's not factorable, move on to one of the other two. Or just stick with one of the two that always works. My motto is this one. I really like the quadratic formula. But you might go, well, factoring's still easy for me. Great, go with factoring until it can't. And then you need to know this one. Right? But just an FYI. Here we go. This is your A. This is your B. This is your C. I just want the numbers. So my A is equal to 1 because there's an imaginary 1 right there. My B is equal to negative 7. The sign goes with the number. My C is equal to 4. After that, you're going to plug it in using parentheses in the formula and then simplify. So here we go. So this becomes negative because it's part of the formula. Parentheses because I have a B. My B is negative 7. So do notice that became a negative, negative 7. Negative was part of the formula. This negative was part of the number. Plus or minus the square root of b squared. So I see the b, so I'm going to open a set of parentheses. I'm going to plug in the negative 7. Close the parentheses. Square goes on the outside of the number. Very important here. Square goes on the outside of the parentheses. Minus, that's part of the formula. 4, that's part of the formula. I see an A, so I'm going to use parentheses, and now I'm going to plug in 1 times C, so I'm going to do parentheses, times 4. And then on the bottom, so all divided. Biggest mistake students make is they'll only divide this part. False. The entire thing is divided, not just a section of it. Over 2 times my A, which is 1. So all I did was just plug in the letters with the numbers. Now I'm going to use GIMDOS or GIMDOS or whatever they're calling it these days to simplify this down. 2 negatives make a. So this is now just a regular old 7. Negative 7 squared would be parentheses matter. 49. Just a note here, this number, when you square it, will always be positive. So if you do get a negative, just change it back to a positive. Minus, what's 4 times 1? Times 4. 16. Good. 2 times 1? 2. Now, if you wanted to do this entire process in one swing, go for it. I would type this entire thing into the calculator, no square root, just the inside right now. I don't touch it. I'm just working with the numbers. Yeah, so I made this 7 a positive. Now everything's been going on in the square root. Everything in the house. I gotta get my house in order, basically. Like chaos. This is all the, in-laws are in, and we're just trying to get it cleaned back up. Just single house. Correct. Perfect. You would try to clean up 33, but the only things that multiply 33 is 3 and 11. Can't go any further. So there's your answer. Didn't have to do no complete in the square, no factoring. Just plug it in and then simplify your work. I do feel that way. They make you want to learn it all. But again, the homework, the test doesn't know which one you use. It just wants the answer. I think quadratic formula is my favorite. Because even if it does come out as things that were factored, I'll show you what happens when that looks like that. But you'll still get the nice clean numbers. Like if the answer was 2 and 3, this will still give you an answer at the end of the day, 2 and 3. And I'll show you that. So, all right, so let's do some more. 5x squared minus 3x plus 2 equals 0. No, I just rewrote the formula. You already have it on this paper. I just wanted to bring it back on my board. I will say we probably won't make it to 16.4, but 16.4 is word problems. So I'll make a little video on that. The hardest part of word problems is taking the words and turning it into this, and then just using whichever process you can to solve it at that point. All right. So this is the next hard. This is probably the hardest part of the entire process. I don't think the math here is that hard, but what I found to be a struggle is students can't tell me right away what my A, B, and C is. So what do y'all think my A is? 5. Perfect. That's your A. -3 would be your B. Perfect. And C would be the 2. Perfect. I don't care about those letters. I just want the numbers with their sign. So make sure the sign comes with it. So if you got this part, I feel that this part isn't so bad. So here we go. So -3 plus or minus the square root -3 squared. Again, every time I plug something in, I'm using parentheses. I want to make sure I'm indicating multiplication. I want to make sure I'm separating the symbols. I don't want to get confused or lost in any of my work. Yep, this is technically what x equals, but I don't really, if y'all didn't write that part, that's no big deal. Because I think on your homework, it already has the x equal typed. You just got to type the rest of it. Two negatives make a. That just turns into a regular old 3. -3 squared, 4 times 5, times 2. Perfect. 2 times 5. 9 minus 40. All right. 31 is prime. There is no other numbers that can multiply 31. But what your homework wants you to do is you gotta get rid of that negative. How do I make that not a negative no more? How do I get rid of a negative inside of a square root? Pull out the I. And then it goes back to just being a positive. 2a, my a was 5. So it became 2 times 5. Oh, does it look like a 9? Oh, because earlier this was a 1, but now it's a 5. So it'd be 2 times 5. Oh, yes, positive 9. That one is a 9. 4 times 5, which is 20, times 2, which became 40. So it became 9 minus 40. But like I said, if you wanted to, I do this. I always separate it as do this work, then this work. But you could technically type this part all into your calculator at once, and it will come back as -31. So so you don't have to stress about doing this part and then this part. That's just what I'm used to doing because, again, I learned this without a calculator, so I try to separate my work. Yeah. I got time for one more, and then we'll go from there. Gotcha. Love that confidence right there. You can do it. X squared plus 9 equals 0. Ooh. Where is, if there's a missing letter? So in this situation, my A is equal to what? Because it's right here. It's right in front of the X squared. What's my B equal to? 0. My B is the number that's next to the X, and there isn't one. So my C, though, is equal to what? 9. Very good. I'll let you keep going. That's good. That's good. Didn't trick you. Yeah, 4 is part of the problem. So there's always going to be a 4 there. Part of the formula right here. Right, did we at least get to the red and plugged it in correctly? I want to check to make sure they got it all plugged in. All right. So this is -0, which is just what? 0. So I actually do not even need this part of it anymore. If you wrote 0, you don't have to worry about it, but you don't technically need it. Plus or minus 0 squared, 0. 4 times 1 times 9, 36. Perfect. 2 times 1, 2. Plus or minus 0 minus 36 divided by 2. Bring out the I, so plus or minus. And then what is the square root of 36? 6. Now this divides. 6 divided by 2 gives me 6, 3. Good. So you get plus or minus 3i, which I believe we did this earlier in 16.1. So you can see that this method also works. Oh, because I don't know what the answer is. Again, if the answer is 2, 2 squared is 4. But if the answer is -2, -2 squared is also 4. So I have no idea if it's a positive or a negative, so we just write a plus or minus. Yeah. If you wrote the 0 with it and you had like 0 plus or minus, there's nothing wrong with that. It's just you don't have to have it. Yeah. All right, but that is the conclusion of today. I will put a 16.4 out there for y'all to work on some word problems. I might actually throw some more 16.3 just to give you some more examples on there. But y'all pretty much have everything y'all need to finish up 16, which is due Sunday. The practice final, huh? Catch up so all makeup work is also due Sunday. All right. So if there's any assignment you miss, you got until Sunday to get those in as well. Because Monday you'll be taking your final, and hopefully on Monday when we come to class, the only grade I'll be missing on your grade book will be the final. So everything else will be there. Correct. 11:59. I have no idea. Computers Monday, calculus Monday, notes Monday. 3 hours on Monday. So that will be the day we're here until 8:30 if you need it. If you finish before then the semester's done earlier.